Okay. So, to review from what we've done before, we've done where if I had 9 and I multiplied it by 1/2, how does that compare to 9? What will happen to my 9? What will the product of 9 times 1/2, will that be greater than, less than, or equal to 9? Andrew?
Less than.
Why?
Because 1/2 is less than.
Because 1/2 is less than 1, the product of 9 times 1/2 will be less than 9. Exactly. So anytime you're multiplying a number by something less than 1, it's going to be less. Oh, it's going to be a long day. What if I did 9 times 5/4? What would happen? What would my end product be compared to 9? Here. Why?
Because it's greater than 1.
So because 5/4 is greater than 1, how do you know that 5/4 is greater than 1? Because it's improper. Because 5 is bigger than 4, it's larger than 1 because it's improper. So because this is greater than 1, your end product is going to be larger than your first factor or your original number. Bless America. Okay. All right. So when we were doing the fractions, I can do the same thing when I apply it to decimals. So if I look at, is that just this right here, how does that compare to 1?
It's less than.
How do you know this is less than 1? Mia? Because there's nothing in front of the decimal. This right here, it has a 0 in the ones place. So it's less than 1. It doesn't matter that there are 9s back there. There's a 0 in the ones place, and 0 is less than 1. And then, there's zeros here too. So since this is less than 1, if I took this and multiplied it by this, my final product, 99 hundredths times 5, it would be less than 5. This is just like a fraction. So because this is less than 1, because 5 times 1 is 5. So because this is less than 1, my final product is going to be less. You were making like a what face. Or you can be like Reagan, and that's just my face. Is that your confused face, or that's just my face? Okay. So what do I know about 1 and 100ths? What do I know about that one? It's greater than 1. Is it a lot greater than 1? No. It's just greater than 1. So if I took this and I multiplied it by 5, how does this product, since this is greater than 1, My end product, how is that going to compare to my first factor? It's going to be greater than 5, because 1 and 100 times 5 is going to end up being greater than 5. You following? Yes, no, maybe? Okay. May not be a lot, but bigger is bigger. Yes, no, maybe? Okay. So, on this part, it's basically a word bank that has numbers. It's a number bank. So I need to look here and see what number could go in each blank to make it true. I have 3 4/10 times something equals 3. 3 4/10. What number up here can go in that blank? I'm going to call A, B, and C. What number can go in there? A, B, or C? C, because it's 1 with nothing behind it. You see what we did there? There's nothing behind that decimal, so it's really just equal to 1. Something times 2100 is greater. Can y'all see this? Something times 2100 is greater than 2100. We have 1 and 21 thousandths and 989 thousandths. Which one of those can go in this blank? We need to make it greater. A. Why is it not B? That one's got like a 9 and an 8 and a 9, and those are really big numbers. There's nothing in front of the decimal, so it's less than 1. Okay, you need to kind of chill, slow the roll, okay? You were just like, you had to go super fast to get it out before anybody else. So kind of chill, twin. So 1 and 2100. It's not a lot more than 1, but it's more than 1. So because this is more than 1, your product is going to get bigger. Yes, no, maybe? We're good? Okay. 8 and 400 times something getting less than 8 and 400. Now, by process of elimination, we should know that it's going to be B, but I always want to check it anyway, because sometimes we can mess up. So we're assuming that it's going to be 989 thousandths. Do we agree that that's what's supposed to go in there? Yeah. Because what Quinn blurted earlier is that because this is less than 1, this whole product should get smaller. So you agree with that? Okay. Okay. So this one looks kind of weird, and it's really not as bad as you think it is. So when it's got these box numbers, now this is the problem set. You're going to get the homework page. I printed out the homework page. It's not homework. This is what you're going to do in class. The weekend. I'm not going to give you homework on the weekend. Okay. I can. All right. So this right here, when it says the product is less than the box number, what they're called, the box number is going to be the first factor. This is your scaling factor. So it's like you're comparing this. You're comparing 13 and 89 times 1 and 4 thousandths to 13 and 89 So you're comparing the box number, your first factor, to the other number, to itself. So you're comparing the box number to itself. The number in the square to itself. They just, for space's sake. So the product is less than the box number, or the product is greater than the box number. So if I have 13 and 89 hundredths times 1 and 4 thousandths, does it go here or does it go here? A or B? Y'all go here. Well, which one? Which here? Here, here, or there, here? So it goes on the right side. Because 1 and 4 thousandths is greater than 1. So 13 and 89 hundredths is times 1 and 4 thousandths is going to get larger, because this number is going to get bigger, because I'm multiplying it by a number that's bigger than 1. Ma'am? No, you don't need to. You're going to get a sheet today. It doesn't have the same numbers. That's why I haven't given it to you yet. 3/10 times, see, I'm going to write this so you can see it. 3/10 times 69 thousandths compared to 3/10. Is it going to less than or greater than? So you're saying, Tamaya's hair in the way?
Yes.
Gosh, Tamaya. Okay, I'm just kidding. So, is it less than or greater than? Why is it less than? So what? So this number is less than 1. 69 thousandths is less than 1, so your product is going to get smaller. There's a lot of quiet people in the room, and then you're going to be later on, I don't understand. I know Quinn understands because he keeps talking the answers, and some people are just kind of sitting back and letting him say everything, and that's not the best way to do stuff. 602 times 489 thousandths compared to 602, because 602 is the one in the box. That's the one that I'm comparing. So is it going to go less than or greater than?
Less than.
Why is it less than? Because 489 thousandths is less than 1. So this whole product is going to go less than. Oh, why did I put a decimal there? I don't know. 602 times 489,000. Going to go over there. So this is pretty like, okay, duh. That's really easy, right? Yes. All right, so I don't need to spend a really, really long time on this.
Yes.
All right. This one. All right. This really is not super duper hard. You just really have to pay attention to your numbers. So when you say slightly more than, what does slightly mean? Just a little bit. So slightly more than, a lot more than, slightly less than, a lot less than. So if you've got a number that's just barely less than 1, it's not going to change the number a whole lot. If it's way far away from 1, then it's going to change it a lot. So if it's barely less than 1, barely more than 1, then that's going to be the slightly. If it's way far away from 1, then it's going to be a lot. So if I have 4 times 988 thousandths, and I'm comparing it to 4. So number one is this, is it going to go 4 times 988,000? Is it going to go less than or more than? Huh? Is it going to be more than or less than? Less than, because it's less than 1. Is it going to be a lot less or slightly less? Slightly. I was listening to you, Antoine. You just weren't answering it as I was asking it. I know you got it. You're good. So, because this is barely less than 1. It's only 12 away from 1. So it's really not going to make a huge change to 4. So slightly, and they're not even asking you to work it. They're just asking you if you can figure out how far away that is from 1. There's a 9/10. That's really not far away. So slightly less. You need to have some sense of numbers to be able to do this. Y'all have sense of numbers? That's not very confident. Do y'all have sense of numbers? Yes. And please stop telling me that 2 times 3 is 5. And 1 times 1 is 2. I am not going to let that die until y'all stop doing it. Okay. So this time my scaling factor is in the front. I can put it in the front. I can put it in the back. You have to pay attention to what number I'm doing. So here's my first factor. That's the number that I'm comparing. My scaling factor is right here. 1 and 5/10. So am I going to go more than or less than? More than or less than? More than. So I'm going to go ahead and put my more than. Is it going to be a lot more or slightly? Slightly. Slightly, because it's not very far away from 1. That's only 5 more. If I've got $1 and a nickel, that's not a whole lot more than $1. So slightly. It's not going to change 8/10 a whole lot. Okay. 1,725, and I'm comparing 1,725. My scaling factor is right here, 13,000. So is my number going to go more than or less than? Less. Because that number, 13,000, is less than 1. Is it a lot or slightly? A lot. I mean, that's not anywhere near 1. I've got a 0 in the 10th place. It's nowhere near 1. So a lot less. Way far away. It's going to be a big change. 989 and 1,000, but I'm doing this one, my first factor, so you can't just assume you know what number. You always need to look in the back. It's not always going to be one number here, one number there. They're going to flip them. So my first factor is this one. My scaling factor is here. So this is the number that I'm comparing to 1. 989. So some people just look at the 1 and go, oh, slightly more than, because it's just a little bit more than 1. Is that the right number to look at?
No.
No. So 989 and 1,000. Is 1 and 3,000 going to go more than or less than?
More than.
More than. Is it going to go a lot more or slightly?
A lot.
A lot. That's 989. That's way more than 1. That's quite a bit. Okay, so my first factor right here, 2,000. I'm comparing 2,000s to 2,000s. 2,000s times 911 thousandths. So am I going to go more than or less than? Less than. Is it going to go a lot or slightly? Slightly. Good. During science class, Teo, Carson, and Zakir measure the length of their bean sprouts. Carson's sprouts is 9/10 times the length of Teo's. And Zakir's is 1 8/10. So this is there. This is Carson. I have to make notes. And Zakir, 1 8/10 times the length of Teo's. Whose bean sprout is the longest? Whose is the shortest? Explain your reasoning. So then we've got Teo. Do we know how long Teo's is? No. We're just going to put it as bean sprout, B. Okay. So this is basically algebra. So I have an unknown, and I am doing an equation where I have an unknown variable. I don't know. But I can find the answers. I'm not really trying to find a number because it doesn't give me a number. But I'm answering a question, who has the longest? Who has the shortest? So I know that Teo has a bean sprout. I know that Carson's is 9/10 the length of Teo's. I know that Zakir's is 1 8/10 the length of Teo's. I guess I didn't need to put the B because it's 1 to T. Whose is the longest? Huh? Not Teo. How do you know it would be Zakir, one of the people that I'm saying there who are saying Zakir?
Because he is like 1 8 times.
So if you've got Teo, if he does 1 times Teo, then those would be even. They would be equal. So they're not equal. It's equal, but more. So it's 1 8/10. So Zakir's is greater because 1 8/10 is greater than 1. So Zakir, D-H, let's make an H, not a K. K-I-R is the longest. Whose is the shortest?
Carson.
Carson. Why is it Carson, Sarah?
Because it's not a 1 in front of you. Decimal.
Because 9/10 is
Smaller than 1.
because 9/10 is less than 1. So if 9/10 is less than 1, then his, whatever he has, the number's going to get smaller. So 9/10 is less than 1. So Carson is the shortest. Teo is actually in the middle. So Teo's here. Carson's is just a smidge shorter. Is it a whole lot shorter? No, it's just slightly less. Zakir's is slightly more. Not a whole lot more, slightly more. All right. Don't let the numbers throw you off. Don't let the letters throw you off. Really, really, don't let the letters throw you off. I know if y'all look at this and you go, what on earth is that? Just like the boats in the marina. You look at it and you go, ah, and then you stop staring at it.
It looks like something I had on my switch.
But, I mean, every time y'all see letters, you just kind of shut down and don't know what to do. But that's why I'm here. If you stop playing with your fingers and stuff, you would learn more. What? Because whatever his length really is, whatever Teo's length really is, if you multiply it by 9/10, it's going to get smaller. Because 9/10 is less than 1. So whatever you multiply by 9/10, what happens to that number? It gets smaller, and that's what Carson has. So Carson's is smaller than Teo. That's what we've been doing the entire lesson. Okay. Okay. So complete the following statements, then use decimals to give an example of each. Okay. When you get into higher math, you're going to do a lot of stuff with letters. It's really, I don't want to say it's really not that hard. It's not hard for me. Mr. Strickland hates doing stuff like this.
He hates math.
But he does kind of hate math. But he is one of those people that says, why do I do that? Why do I put this over here? Why do I put this over here? Why do I do that over there? Me, I'm like, oh, you want me to put that there? All right. Doom, 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 doom. I'm done. I don't ask why. You told me to do it. I did it. I'm done. So this kind of stuff, I love doing it because you tell me to plug a number. If A is 5, I put a 5 everywhere there's an A. I'm done. I got an answer. So with some things, you can't ask why. You just plug a number in there, and you get an answer out. Plug and chug. Plug a number in, chug an answer out. You're done. If you spend your entire time asking why you get an answer, you are going to struggle. Like algebra. You can't ask why. You just do it. So he always asks why. I had to tutor him in college. Hey, when I tutored him, he made 8. Okay. So complete the following statements when you then use decimals and give an example. So A times B. A number times a different number. A and B. Those are 2 different numbers. If I wanted them to be the same number, I would have to use what? Huh? The same letter. So this.
So it's
It's not kind of easy.
that. So you just put a number in A, and then times that number, that would equal A, but they have to be the same number.
So a number would be greater. We've been doing this all day. Will always be true when this is what? So A times B will be, stop looking at your fingers, Hunter. A times B will be greater than A when B is, huh?
Greater than 1.
Oh, Andrew got a high five. Why? He just got my cooties. I've been coughing all morning. I've been coughing in my jacket. I'm kidding. So A times B is greater than A when B is greater than 1. Whether it's a fraction, whether it's a decimal, whether it's a regular number, if it's greater than 1. We had done fractions. We have done decimals, you can do 2 as long as it's greater than 1. This will always be true. So an example, if you have 2 times this, A times B will always be greater than A.
Do we write this down?
You want to?
I
A times B will always be greater than A. 2 times 1 and 1,000
just don't like what you said.
will always be greater than A. See how I use the same number for the same letter. As long as B is greater than 1. Every time. You're like, I already knew that, bro. I already knew it. Why are you telling me again? I already knew it. But did they try to kind of throw you off using what's called the theorem? This is like the math rule. They use letters when they're trying to use like just general stuff. Because if I give you the straight up numbers, you're going to be like, but it's not 1 in 1,000. This one has 1 in 5,000. It's different. Sometimes you guys get so literal with everything. When we change the numbers, you think it doesn't apply because it's a different number. So when you do letters, it's any number. A times B is always true. A times B is always greater than A when B is larger than 1. Yes, Mia? I can do X times Y is greater than X. You can use any letter, but they tend to like, A and B and C because they're in the front. X, Y, Z, doesn't really matter. L, M, N, it really doesn't matter. They just use letters. Yeah.
Is there like a letter sentence for less than 1? Oh, I see.
A times B less than A will always be true when B is less than 1. Whether it's a fraction, whether it's a decimal. I can't use a whole number this time unless it's 0 or a negative. But we don't do that in here. You'll do it higher. You'll do it in a higher grade, just not here. So A times B less than A is always, always true as long as B is, I do that wrong every time, less than 1. So it can be less than 1 decimal. It can be 1/2, 3/4. Anything that is less than 1. You're spending more time tipping that chair than you are paying attention, and that is a disservice to me and you. Yes, sir. I'm sorry, what? Well, you can't see over Eli's head because you're not sitting up straight, and you've got a water bottle in front of your face. So that's on you. Sit up. I mean, I can't see stuff when I'm down on the desk like this either. No, well, no, because he's not sitting up straight. That's on him. Sit up straight. Okay. Oh, that was from the exercise. Will the product of 22 and 65/100ths times 999 thousandths, will it be greater than or less than 22 and 65/100ths? Now it says without calculating. And what's funny is it'll say without calculating, don't solve it, and I'll have you sit there and try to solve it. Do you have to solve it? No. Explain how you know. Except for Quinn. I love you, Quinn, but not right now, because you've been answering everything. Alea.
It would be less than because 999,000 is less than 1.
Because 999 thousandths is less than 1. So you see that? Because 999 thousandths is less than 1, the entire product is less. It brings the number down. Not a whole lot, but it still brings it down. And I know that if you tried to do this, even though it says don't, if you tried to multiply this, a lot of you would not be successful. Please don't calculate it. Do not, because it says without calculating. Don't. But nothing. It says don't. I'm not asking you to. It says don't.